Let's switch from vector analysis to some algebra to find the momentum, which is the magnitude and direction that M2, which is the bowling pin, leaves with after the collision. So here's the problem statement. You have a momentum here of M1, and then you have the momentum of M1 after the collision, and the angle it takes off with respect to the x-axis. The nice thing here is we don't have to worry about the masses because we're just calculating momentum, and the problem is find the final momentum of the pin. An excellent way to start any physics problem is with a nice sketch, which we have, and then list your givens. We know that mass 2 is at rest, so it has no momentum either in the x direction or the y direction. Mass 1 has a momentum in the x direction, nothing in the y. We come over here, here's our given, and we right away resolve this vector into its x and y components. The x component is going to be the hypotenuse, which is 12 times cosine of the angle here, 60 degrees. The y component is going to involve the sine function. So that's what we have here. So now we have our final momentum of the bowling ball broken down into its x and y components. What we want to find is the momentum of the pin, and that's this vector right here. Now if we draw a right triangle there, we know that this is going to be P2x and this is P2y. So to find the magnitude of the hypotenuse, we just use Pythagoras here. And you can see how we have the primes indicating this is the final momentum. To find the angle theta, we just use the arctan function. It's equal to this side, the magnitude of this side, opposite, over adjacent. And the adjacent side is the x component. And here we have the equation we're going to use to find theta. We'll use the conservation of momentum in the x and y directions. Let's start with x. We have the initial momentum in the x plane for both objects equals the final momentum. Again, don't put any numbers in until you have your variable isolated. We want to find p prime of 2x. So we get that over to the left, everybody else is on the right. Now you can put the numbers in. We have the initial momentum of object 1 in the x direction is 20 kilogram meters per second. There is no momentum in the y direction. And here's the final momentum of object 1 in the x direction, 12 cosine 60. Keep the units outside here just so we don't have to put them next to each number. And we find that p prime 2x is 14.0 kilogram meters per second. Now, in the y direction, very similar, except here we're solving for p prime 2y. We isolate the variable. We substitute in our numbers. And again, that's why it was handy to have a section that showed our given. And of course, we derive this by basically using a variant of Pythagoras. Add the numbers, and we have p2 prime y is negative 10.4 kilogram meters per second. And that makes sense. You can see how the x component is positive and the y component is going to be negative as it's pointing down. We have the x and y components of the final momentum of object 2, the bowling pin. So we go to Pythagoras to find the magnitude of the vector right here. That's where the momentum is directed. You just square these terms and take the square root. Notice how we don't care about the negative sign here. We just square it. And we get a final momentum, magnitude of momentum for the bowling pin of 17.4 kilogram meters per second. Now we want to find the angle theta. That is equal to tan inverse of the momentum in the y direction divided by the momentum in the x direction. We put the numbers in here, and here we see the angle will come out to be negative. The tangent function is negative in the fourth quadrant, and we get an angle of negative 36.6 degrees. Or we could also say it is 36.6 degrees south of the x-axis. Or we could have a picture and just point to the angle and put the number. That's also a good way of doing it. Anything that makes it clear to whoever is working with you.